Hi, this is Sindhu Ernala, and on behalf of my co-authors Stephanie, Yuxi, Rachel, Kristen, and Sauvik, I'm going to talk to you about our CSCW paper on dynamic audience selection on Facebook. Knowledge of one's audience influences whether, what, and how one communicates. And this is true for social media platforms where people may communicate with many different audiences at the same time. Despite the critical importance of audience in posting decisions on social media, audience selection controls have largely remained unchanged for over a decade. Today, people select between pre-configured static lists of their contacts. For instance, on Facebook and Instagram, users typically choose between all of their friends or the public settings. Otherwise, they create manual lists such as close friends or acquaintances to support finer-grained audience selection. More recently, Twitter added a new feature allowing users to limit who replies to their posts. However, these static approaches to audience selection have well-noted shortcomings. The lack of awareness of one's audience and misalignment between imagined and actual audiences have led to well-documented privacy violations. Consequently, users adopt a variety of boundary regulation strategies to navigate context collapse, especially in a network composed of multiple overlapping social circles. A notable strategy here is only posting content for the lowest common denominator. That's content that is appropriate for all overlapping social circles. Another strategy is self-censorship. Prior work found that people censor more on social media when their audience is hard to define and when the relevance of the content they would share is much narrower. Lastly, users also experience regret for sharing content that might be inappropriate to some parts of their audience. Owing to these challenges with static audience selection controls, prior work suggests that there is potential utility in designing dynamic audience selection controls, those that better align users' actual and their imagined audience. For instance, imagine restricting audience to only friends who like basketball, or friends who live around me, or friends who went to the same school as I did. Although intelligent audience selection controls may unlock more utility, designing something like this is not straightforward. Employing AI to facilitate intelligent audience selection tools requires an algorithm that can make potentially invasive inferences about one's connections. And this trade-off between the utility and intrusiveness of dynamic audience selection controls remains unstudied in our community, especially from the end user's perspective. And without figuring this out, it's hard to determine if such controls should be implemented. In this work, we bridge this gap and explore dynamic audience selection for Facebook. We asked 2 research questions, but in the interest of time, I'm focusing on the second question, which looks at the perceived utility, intrusiveness, and the trade-offs between the two for dynamic audience selection tools. To answer these research questions, we adopted a combination of survey, design, and evaluation as our methodology. In the interest of time, I'm mainly focusing on the evaluation step in this talk. First, we created a sensitizing prototype of an intelligent dynamic audience selection mechanism for Facebook. We started our prototype design by parallel prototyping on paper and then improving the fidelity of the prototype over several iterations. Several considerations went into our prototype design that we go into more detail in our paper. This is how our DAS prototype looked. Underneath where a user would type out the post, we added a second text box where the user could specify their audience. They can use the plus symbol for targeting a specific audience group or a minus symbol for filtering them out and blocking them from seeing the post. Based on the user-specified audience constraints, DAS algorithmically categorizes people in their social network into relevant audience categories and displays these recommendations. Finally, users can click on the audience categories generated by DAS to view who among their friends were predicted to belong to a specific constraint. And at this point, they can make any changes that the algorithm missed. And once they're happy with the audience selection, users can go ahead and post. To understand the trade-offs between utility and intrusiveness of DAS, We conducted task-based testing that involved participants using our sensitizing prototype for hypothetical audience selection scenarios on Facebook. After prototype walkthrough, we shared the hypothetical scenarios with our participants, and we asked questions around how they would use DAS for that specific scenario, how they would use Facebook as is, and given the considerations that go into having something like DAS, for instance, that it's data-driven, the predictions could be error-prone, etc., we asked our participants how they felt about the tool. We recruited 23 participants between August and September 2020 and conducted a within subjects design for this user study, in which each participant interacted with the prototype under 3 different posting scenarios. We analyzed qualitative data, and facilitator observations also informed our final findings. Moving on to some key findings, participants shared that DAS might help reduce context collapse on Facebook, contributing to the potential utility of the tool. P8 talks about multiple overlapping social circles that hindered them from fully expressing themselves on the platform. And being able to maneuver different social circles as audience might encourage them to post more on Facebook. Some participants were hesitant to trust their algorithm for more nebulous categories like political affiliation or people's stances on different issues. P2 here talks about distrust in algorithmic inferences that brings down the potential utility that they draw from DAS. Now, while some participants were excited about DAS's potential for introducing them to new friends and helping them learn more about existing friends, others were concerned that it would reveal things about their friends that they did not want to know, or reveal things about themselves that they did not consent to sharing. For instance, P4 says, I don't want an algorithm to label someone in my family. I want myself to label them. Someone might have a nuanced opinion about a polarizing topic, and an algorithm making judgment calls and labeling people based on an ideology seems wrong to me. And this reveals the potential introduction of privacy-intrusive side channels with something like DAS. P20 says, I think I'd actually go to their profile and check, what do they post that they're categorized this way? If an algorithm told me that my friend had controversial views, and it was way later into knowing them, I would be pretty shocked. P20 here is essentially appropriating DAS's inferences to learn new information that they would otherwise not be able to access about their friends. We found that the stakes of a posting decision defined the trade-offs between utility and intrusiveness of DAS. P3, for instance, found it difficult to justify the potential privacy intrusiveness of DAS for low-stakes scenarios. That's scenarios where errors in audience selection would not be a significant concern. On the other hand, the probabilistic nature of DAS made some participants hesitant to use it for high-stakes sensitive scenarios. These findings strengthen what we know from prior literature, suggesting that more granular audience controls would help people censor less and reduce interpersonal privacy violations due to context collapse and inappropriate access. However, in this case, distrust in the algorithms powering DAS and the uncertainty around prediction errors reduced its utility. Moreover, owing to the introduction of privacy-intrusive side channels, many participants found the concept to be intrusive. On balance, participants' perceptions of low reliability and intrusiveness of DAS outweighed the utility they saw for both low-stakes and high-stakes posting scenarios. In our paper, we discussed the design implications of this work in more detail, specifically the opportunities where potential utility of something like DAS might outweigh intrusiveness. For instance, we discussed different intelligent sorting algorithms that can generate predefined lists of audience groups based on user-generated constraints, instead of doing this on the fly per post. Our findings also suggest that posting stakes play a significant moderating role for audience selection preferences on Facebook. Future work might look at different posting scenarios and their stakes more deeply and further explore how dynamic audience selection might apply to different contexts. Please check out our paper for more details. Thank you for listening.